Section 2.2, Adding Integers. In this video, we will learn the definition of a vector and how to use vectors to add integers on the number line, the relationship between a vector magnitude and an absolute value, how to add integers with like signs, how to add integers with unlike signs, properties for adding integers, how to add more efficiently with properties for adding integers. Like our work with the whole numbers, addition of integers is best explained through the use of number line diagrams. However, before we start, let's take a moment to discuss the concept of a vector. Vectors. A vector is a mathematical object that possesses two import qualities. 1. Magnitude or length, and 2. Direction. Vectors are a fundamental problem-solving tool in mathematics, science, and engineering. In physics, vectors are used to represent forces, position, velocity, and acceleration, while engineers use vectors to represent both internal and external forces on structures such as bridges and buildings. In this course and in this particular section, we will concentrate on the use of vectors to help explain addition of integers. Vectors on the number line. Consider the number line in Figure 2.4. Above the line, we've drawn a vector with tail starting at the integer 0 and an arrowhead finishing at the integer 4. There are two important things to note about this vector. 1. The magnitude or length of the vector in Figure 2.4 is 4. 2. The vector in Figure 2.4 points to the right. We will agree that the vector in Figure 2.4 represents positive 4. It is not important that the vector starts at the origin. Consider, for example, the vector pictured in Figure 2.5. Again, there are two important observations to be made. 1. The magnitude or length of the vector in Figure 2.5 is 4. 2. The vector in Figure 2.5 points to the right. Hopefully you have the idea. Any vector that has length 4 and points to the right will represent positive 4, regardless of its starting or finishing point. Conversely, consider the vector in Figure 2.6. which starts at the integer 4 and finishes at the integer -3. Two observations. 1. The magnitude or length of the vector in Figure 2.6 is 7. 2. The vector in Figure 2.6 points to the left. We will agree that the vector in Figure 2.6 represents -7. We could select different starting and finishing points for our vector, but as long as the vector has length 7 and points to the left, it represents the integer -7. Important observation. A vector pointing to the right represents a positive number. A vector pointing to the left represents a negative number. Magnitude and absolute value. In Figure 2.4 and Figure 2.5, the vectors pictured represent the integer positive 4. Note that the absolute value of 4 is 4. That is, the absolute value of 4 equals 4. Note also that this absolute value is the magnitude or length of the vectors representing the integer positive 4 in Figure 2.4 and Figure 2.5. In Figure 2.6, the vector pictured represents the integer -7. Note that the absolute value of -7 equals 7. This shows that the absolute value represents the magnitude or length of the vector representing -7. Magnitude and absolute value. If a is an integer, then absolute value of a gives the magnitude or length of the vector that represents the integer. Adding integers with like signs. Because the positive integers are also whole numbers, we've already seen how to add them in Section 1.2. Example 1. Find the sum 3 plus 4. Solution. To add the positive integers 3 and 4, proceed as follows. Start at the integer 0, then draw a vector 3 units in length pointing to the right as shown in Figure 2.7. This arrow has magnitude length 3 and represents the positive integer 3. Draw a second vector of length 4 that points to the right, starting at the end of the first vector representing the positive integer 3. This arrow has magnitude or length 4 and represents the positive integer 4. The sum of the positive integers 3 and 4 could be represented by a vector that starts at the integer 0 and ends at the positive integer 7. However, we prefer to mark the sum on the number line as a solid dot at the positive integer 7. This integer represents the sum of the positive integers 3 and 4. Negative integers are added in a similar fashion. Example 2. Find the sum -3 plus -4. Solution. To add the negative integers -3 and -4, proceed as follows. Start at the integer 0, then draw a vector 3 units in length pointing to the left as shown in figure 2.8. This arrow has magnitude length 3 and represents the negative integer negative 3. Draw a second vector of length 4 that points to the left, starting at the end of the first vector representing the negative integer negative 3. This arrow has magnitude length 4 and represents the negative integer negative 4. The sum of the negative integers negative 3 and negative 4 could be represented by a vector that starts at the integer 0 and ends at the negative integer negative 7. However, we prefer to mark this sum on the number line as a solid dot at the negative integer negative 7. This integer represents the sum of the negative integers negative 3 and negative 4. Drawing on physical intuition. Imagine that you are walking the number line in figure 2.8. You start at the origin 0 and take 3 places to the left. Next, you walk an additional 4 paces to the left, landing at the number negative 7. It should come as no surprise that the procedure used to add 2 negative integers comprises 2 steps. Adding 2 negative integers. To add 2 negative integers, proceed as follows. Add the magnitude of the integers, then prefix the common negative sign. Example 3. Find the sums a, negative 4 plus negative 5, b, negative 12 plus negative 9, and c, negative 2 plus negative 16. Solution. We'll examine 3 separate but equivalent approaches as discussed in the narrative above. A. The number line schematic shows that negative 4 plus negative 5 equals negative 9. B. Drawing on physical intuition, start at 0, walk 12 units to the left, then an additional 9 units to the left. You should find yourself 21 units to the left of the origin. Hence, negative 12 plus negative 9 equals negative 21. C. Following the algorithm above and adding 2 negative integers, first add the magnitudes of negative 2 and negative 16. That is, 2 plus 16 equals 18. Now prefix the common sign. Hence, negative 2 plus negative 16 equals negative 18. Adding integers with unlike signs. Adding integers with unlike signs is no harder than adding integers with like signs. Example 4. Find the sum negative 8 plus 4. Solution. To find the sum, proceed as follows. 1. Start at the integer 0, then draw a vector 8 units in length pointing to the left as shown in figure 2.9. This arrow has magnitude length 8 and represents the negative integer negative 8. Draw a second vector of length 4 that points to the right, starting at the end of the first vector representing the negative integer negative 8. This arrow, also shown in figure 2.9, has magnitude or length 4 and represents the positive integer 4. The sum of integers could be represented by a vector that starts at the integer 0 and ends at the negative integer negative 4. However, we prefer to mark this sum on the number line as a solid dot at the negative integer negative 4. This integer represents the sum of the integers negative 8 and 4. Drawing on physical intuition. Imagine you are walking the number line in figure 2.9. You start at the origin and walk 8 paces to the left. Next, turn around and walk 4 paces to the right, landing on the number negative 4. Note that adding integers with unlike signs is a subtractive process. This is due to the reversal of direction experienced in drawing figure 2.9 in example 4. Adding 2 integers with unlike signs. To add 2 integers with unlike signs, proceed as follows. Step 1. Subtract the smaller magnitude from the larger magnitude. Step 2. Prefix the sign of the number with the larger magnitude. For example, to find the sum negative 8 plus 4 of example 4, we would note that the integers negative 8 and 4 have magnitudes 8 and 4 respectively. We would then apply the process outlined in adding 2 integers with unlike signs. Subtract the smaller magnitude from the larger magnitude, that is 8 minus 4 equals 4. Then prefix the sign of the number with the larger magnitude. Because negative 8 has the larger magnitude and its sign is negative, we prefix a negative sign to the difference of the magnitudes. Thus, negative 8 plus 4 equals negative 4. Example 5. Find the sums a, 5 plus a negative 8, b, negative 12 plus 16, and c, negative 117 plus 115. Solution. We'll examine 3 separate but equivalent approaches as discussed in the narrative above. A. The number line schematic shows that 5 plus negative 8 equals negative 3. Drawing on physical intuition, start at 0, walk 12 units to the left, then turn around and walk 16 units to the right. You should find yourself 4 units to the right of the origin. Hence, negative 12 plus 16 equals 4. C. Following the algorithm and adding 2 integers with unlike signs, subtract the smaller magnitude from the larger magnitude, thus 117 minus 115 equals 2. Because negative 117 has the larger magnitude and its sign is negative, we prefix a negative sign to the difference of the magnitudes. Thus, negative 117 plus 115 equals negative 2. Properties of addition of integers. You will be pleased to learn that the properties of addition for whole numbers also apply to addition of integers. The commutative property of addition: let a and b represent two integers, then a plus b equals b plus a. Example 6. Show that 5 plus a negative 7 equals negative 7 plus 5. Solution. The number line schematic shows that 5 plus negative 7 equals negative 2. On the other hand, the number line schematic negative 7 plus 5 shows that negative 7 plus 5 equals negative 2. Therefore, 5 plus negative 7 equals negative 7 plus 5. Addition of integers is also associative. The associative property of addition: let a, b, and c represent integers. Then, whether we group a and b or b and c, the two expressions are equal. Example 7. Show that the expression with negative 9 and 6 grouped is equal to the expression with 6 and 2 grouped. Solution. On the left, negative 9 plus 6 equals negative 3. Then negative 3 plus 2 equals negative 1. On the right, 6 plus 2 equals 8, and negative 9 plus 8 equals negative 1. Both sides simplify to negative 1, therefore the two expressions are equal. The additive identity property. The integer 0 is called the additive identity. If a is any integer, then a plus 0 equals a, and 0 plus a equals a. Thus, for example, negative 8 plus 0 equals negative 8, and 0 plus negative 113 equals negative 113. Finally, every integer has a unique opposite called its additive inverse. The additive inverse property. Let a represent any integer, then there is a unique integer, negative a, called the opposite or additive inverse of a, such that a plus negative a equals 0, and negative a plus a equals 0. Example 8. Show that 5 plus negative 5 equals 0. Solution. The number line schematic clearly shows that 5 plus negative 5 equals 0. Important observation. We have used several equivalent phrases to pronounce the integer negative a. We have used the opposite of a, negative a, and the additive inverse of a. All are equivalent pronunciations. Grouping for efficiency. Order of operations require that we perform all additions as they occur, working from left to right. Example 9. Simplify negative 7 plus 8 plus negative 9 plus 12. Solution. We perform the addition as they occur, working left to right. Negative 7 plus 8 is 1. Then 1 plus negative 9 equals negative 8. Then negative 8 plus 12 equals 4. Thus, the answer is 4. The commutative property of addition tells us that changing the order of addition does not change the answer. The associative property of addition tells us that a sum is not affected by regrouping. Let's work example 9 again first, grouping positive and negative numbers together. So, example 10, simplify the same expression using the commutative associative properties that allow us to change the order of addition and regroup. So first, use the commutative property to change the order, placing the negative numbers together and the positive numbers together. Then use the associative property to regroup. Then add the negatives. So negative 7 and negative 9 is negative 16. And add the positives. 8 plus 12 equals 20. Then negative 16 plus 20 equals 4. At first glance, there seems to be no advantage using the technique in example 10 over the technique used in example 9. However, the technique in example 10 is much quicker in practice, particularly if you eliminate some of the explanatory steps. Efficient grouping. When asked to find the sum of a number of integers, it is most efficient to first add all the positive integers, then add the negatives, then add the results. Example 11. Simplify negative 7 plus 8 plus negative 9 plus 12. Solution. Add the positive integers first, then the negatives, then add the results. Adding the positives, 8 plus 12 equals 20. Adding the negatives, negative 7 plus negative 9 equals negative 16. Add the results, 20 plus negative 16 equals 4. Using correct notation, never write plus minus. That is, the notation 9 plus minus 4 and negative 8 plus minus 6 should not be used. Instead, use grouping symbols as follows: 9 plus grouping symbol negative 4, and negative 8 plus grouping symbols negative 6.